Hi, welcome to this fifth day of DebConf in the afternoon, and welcome to everyone online. And I'll let Liso Han talk about Linux container. Thanks a lot.
Thank you. Hi, welcome to my session, and today I'm going to talk about Linux containers with AppArmor Policy Namespace. So let me introduce myself first. I'm Liso Han. I'm a research engineer at WeWake Corporation, and I'm responsible for embedded Linux kernel system and containerization. So today we take a look at overview of container and AppArmor first, and then see the practical issue happening in automotive industry, then explain why policy namespace is used. And then finally, I'm going to wrap it up everything with pros and cons and show you, let me show you a little bit demo. So Linux container is a technology that shares Linux kernel, isolate its own process, and can have different system functions. Each container has the same program, but they run on a different set of system functions, which might include different versions of libraries or even the root file system. And this picture is about OS security, and AppArmor is a security module on the OS side. It works with a set of policies and operates between the early and final stage of system calls. Since a sysadmin defines AppArmor policy for a specific program by its path, it can reject any system call from a program with the same path because AppArmor works based on the path of the program. And recently, automotive industry tried to adapt multiple functions in a physical computer. Therefore, virtualization technology have been important for years with two major solutions, virtual machines and container. However, VM is off topic for this section. Anyway, recently there has been an effort to integrate various functions into Beehive, such as entertainment, Android platform, and so forth. That's why containers are being used in the industry. However, it offers benefits such as quick and easy integration, resource control with C groups, being a lightweight virtual machine, and enhanced security through isolation. Even though a set of processes working in a container doesn't affect the host, OS security is still important. This is because if a container itself has vulnerabilities that haven't been found yet, it could let its own process have permissions to the host. Additionally, the host needs security hardening for a set of its process as well. So combining containerization and security modules like AppArmor would look like the picture. The purple circle represents system call, which is the well-known user interface. The user space is on the left side, while the kernel is on the right side. There are many processes running not only in container, but also on the host, and the kernel works with the security module. So the system has two parts of security, one for containers and another for the host. Finally, we have full security functions for every process in the system. Let's imagine you built a system like the one shown on the screen with a couple of containers and a kernel working with AppArmor. You want ping program to work properly on the host while the same program in a container is not allowed, regardless of the kernel implementation. That's the system you want to function. The ping process running on the host should return success, while the one in the container should result in an error. So you define a policy and load it to the kernel for the container. But in fact, all system calls from process, whether from the host or containers, are affected by the exact same policy without namespace as shown on the screen. Therefore, you cannot expect them to work as we looked in the previous slide. As a result, the ping process on the host would also receive an error. That's why policy namespaces were introduced. AppArmor can have multiple namespaces with a set of categorized policies. Containers with a policy namespace are very efficient because one namespace cannot affect another. Therefore, the system becomes more flexible. Let's look at the diagram again. It's almost the same image as we saw before, but now AppArmor has its own policy namespace, as shown on the screen, with namespace 1 and 2 in each area with the red box. But the difference is that you could use namespace 1 for running the ping process on the host, while using namespace 2 for the same program in containers. Therefore, the host process works properly as we expect, but a process in a container would be rejected by policy namespace 2. Eventually, you can control a set of process with policy namespace regardless of whether they are run on the host or in containers. So let me wrap it up with pros and cons. Okay. It enhances security and flexibility, operates independently, and avoiding conflict. So therefore, your system becomes more powerful. But on the other hand, managing multiple policy namespace can be more complex than doing so for a single policy set. So a sysadmin needs to understand how to create and manage namespace effectively, which can require additional training and knowledge. So now I will show you a little bit demo. Okay, so this is my system. I will show you a container first. Here is the one container working under my system, which is based on Fedora 40. And this is also working with the, working on the namespace, which we can see.
Can I do the font?
Oh, yeah, sure. Hold on.
Thank you.
Is it okay?
Yeah.
Yeah, okay. So let me show you, let me explain. So, this blue line, which means like does kind of process working in a container with container namespace. And I will show you the policy file I defined, which is a ping program. But when it runs in the container, it will get reject. When it tries to send ICMP package to the host, it will reject by the AppArmor with the container namespace. So let me move to the container. This is inside the container. And I will try to ping to the host right now without any policy. Then it works very well. But now I'm going to load my policy file to the kernel with the namespace. And now I'm going to try again to the host, but it got permission denied. So let's see what's going on behind it. And ping again through strace is you can see that when ping process tried to call socket system call, it got rejected with permission denied by AppArmor. But the funny thing is that it still got permission denied through inside kernel, inside container. But when you try to ping to the world on the host, it works. It works very well. Like it still works very well. But on the in the container, it doesn't work. So now let me remove the policy from the container namespace, and then try again inside the container. But it works very well. So that means like we could have different namespace between host and containers. So my session, that's it for now. So if you guys have any questions, feel free to ask me. Thank you.
If I use SC Linux, same namespace, same policy namespace is available.
So your question is that if you try to use SE Linux, you can have the same functionality as AppArmor, right?
Yeah, something like a policy namespace separator.
As far as I know, that's not possible because, I mean, Linux security module maintainers are still working on the namespace implementation, but they don't. But the core maintainers of Linux kernel, they don't like to have that kind of functionality for SE Linux and Snacks. So that's the lacking of the part for now.
Thank you.
Any question? Any other question? So, thank you so much. Thank you for your talk. Hope to see you soon. Thanks to everyone.
And if you guys have any questions during the conference, feel free to ask me anytime, anywhere.